You are watching
3
Xirtus.
nanometer process is really important because once you start to get below 1 nanometer, then that's when you're going to have to start worrying about things like you were talking about, like neutrinos or spacers, and also why we would move away from electricity towards light, towards photonics and everything. But we're just not quite there. So we have another 10 years, probably, I would say, before we start to really see consumer products that use photonics instead of just electricity. But that's going to require, I think, standardization, right? So we're going to see RISC-V before we see that. Um, but yeah, three
Right.
nanometer process exists now, and so that is the same thing where you have it's essentially done the same way a film is made. So you have a chemical layer that removes the entire layer that's a certain light frequency. Like this color is because that was the particular par density, and then this par density was a different par density, right? And we've shown what that looks like here. But if you are able to dial it in and probe just the 400 nanometer, or just the 650 nanometer, just the 641 nanometer, maybe just get 651 to 649, like just in between on the other side of that bar, then you're able to like
And this
wash away.
determines the depth of the what's lasered away, or
Right, absolutely.
hmm
And then
hmm
how many layers there are, like a 3D printer. So you might have a layer and another
and then
layer.
afterwards you have to add, let's say, quote unquote, metal to it, or how, or is it
No,
done?
often it's you start with a wafer that has metal and it's got chemicals in it that burn away, right? So when the light hits it, that burns away the material. So this is kind of like, let's look at 7 layer perforation film, because this is a similar chemical process. Um, so first you have a sputtering process where this celluloid is sputtered with this thin layer of the material, and you do that 6 times or 7 times in order to get different chemicals that are reacted to different light. And then when the light hits it, it burns away one layer or another layer depending on the frequency of light, and you have
So
just some silver there. Or
this means if the wafer is properly designed and the whatever CNC machine or however it would be called, and the laser device is set up properly, then I could have completely standardized wafer production and yeah, basically have, yeah.
yeah,
I imagine
but
like I just laser it and then the thing is complete, or I'm stacking more. Because I really don't know how complex actually how complex the process of the manufacturing of current chips
I
is.
mean, it's non-trivial. Like you need to wear crazy clothes because you can't have anything touch the thing. You have to be in a separate room
And
usually.
also, what we should discuss here, or I want to ask what your thoughts about this are. I had heard this idea many years ago from a friend, and then recently also from David. I think he also mentioned on shows, and certain other people sometimes talk about this idea or this question, to what extent these new developments are really new developments, or to what extent, I don't know, technology was
Well,
given, or however you want to call it,
so
and it's just being released and, as you said, then adapted for mass production. But it's not really that some scientists at AMD or Intel come up with some eureka, but at a certain time, I'm not sure how this would work, but with such big structures, you could,
so look at this right here, right? So
have a
this is a
funnel
picture.
of information.
Here's a
Yes?
picture. Here's a picture of film, right? And in that film, you see like hairs and artifacts and grain. So this is the same technology that's making those silicone wafers, and this is why it's so difficult to make a perfect silicone wafer, because organic artifacts occur and it completely destroys hundreds of these chips at once, right? And so that's why it takes a lot of effort to keep it super clean, and also why the chemicals have to be perfectly dialed in, and the color and everything. And so yeah, I mean, this technology's existed for a long time, and they've been using it for chips for a long time. But it started with light tests and with aperture readings and trying to figure out, could we use this to photocopy a design, and then also could we make layers in it. So I mean, could this have existed for a very long time? For sure. And using lenses, could you make them smaller and smaller? But once we knew that, I think once mathematicians and engineers figured that out, that became a path. And so that's why we talk about Moore's law, because they said, okay, well then what we'll do is we'll do this every year. Maybe it'll go faster, but at very least we're going to have deadlines that we'll get this done every year. And by the end of the century, we're going to get to a point where we'll be too close together to get any closer without there being light and electricity literally just next to itself. And so that, I mean, it's not that out of control of the theory, and it doesn't mean you couldn't do it sooner. They weren't saying, oh, we're just going to keep it until we get to that point. Corporations kind of did at a certain point, but not until the 90s. In like the late 90s, they started coming up with quarterly and annual progressions of technology. Before 1999, I mean, you could just like buy a computer and throw it in the trash by the time you got it paid for at the counter, because there's a new computer coming out every second.
Oh, really?
Right?
It was that
Yeah.
fast? Okay. Wow.
In the
Okay.
90s, it was crazy. In the 90s, just like every moment, there was this computer, that computer, this company, and it wasn't until like CES and the E3s and things like that they
So
started
suggesting
saying,
that actually slowed it down. So one new smartphone a year is not so bad, actually. All right. Okay.
they slowed it down. It should be one a year at least, maybe two a year, because you want to have a revision version of the product, at least, so that by the time the new chip comes out, there's already revisions done that we've worked on with the old one. So this is why they kind of do like one foot after another. But there's no reason why it has to be that slow. I mean, you could have companies taking higher risk.
Higher risk. Yeah. And because the other question, of course, is I would agree that if you have a certain path, you can follow it through, you can do it faster or slower. The other question, of course, would be, are there any, or maybe there have been competing technologies that for various reasons simply had not been used because they maybe operate on different principles or something?
I love the website FIRPA, high risk, high payoff research. I mean, this is for the most brilliant of naive engineers, because what they do is they get people like, oh, you're really smart. Well, but you can't figure out how to sell that, can you? Oh, well, we're good business people. Oh, we're gonna
We'll
learn
only take
you.
99% on all the licensing. Yeah.
Oh, but sure, you're gonna learn a lesson, boy. You're gonna learn. You're gonna learn from us. That's how it feels. I don't trust IARPA that much anymore. But they do great things. I mean, because a lot of great people end up doing projects for them. But I don't know. That's the thing with film, though, is that we will get to a point where you won't need to use film, because you'll use electrons to literally like arrange the material the way you want. And maybe we'll get to a point, people talked about in the 90s organic chips, where using biomolecular printers in vegetable matter, you could literally arrange and print chips, and that idea of like growing computer chips, you can do it. Like it would be the best way to do it, because then it could arrange in such a perfectly close way with everything. So we're going to get to a point where all computers are organic, literally.
But then at least they can start finally rewiring themselves.
Yeah.
Yeah, because that for me, with the whole AI talk, this at least would make it somewhat more likely that it could connect to some kind of an intelligence, if at least by itself it has the real capacity to rearrange, just like humans naturally do, right? Rearrange its own composition. That's great. Yeah, that would save a lot of money, I guess, eventually.
Hopefully not.
If you need no more
Hopefully things just grow, is the idea on the side. Well, computer weeds on the side of the road, and they'll be organic, and they'll be edible. You'll be able to eat them before they go bad. Like, hey, you better eat those computer chips. Like, they're getting stale.
Yeah, well, if the silicium is in a way that's bioabsorbable, it may even be healthy for humans. Yeah, that'd be that would be a fun techno Gaia utopianism you're always talking about.
You got to make everything. Yeah, you got to make everything better. That's the thing. All right, Mark Rubio, I don't know if anyone's got any opinions, let me know. The only thing I know that I really care now is that he's against Risk 5, and that's a risk to your democracy.
Just an old-fashioned techno song. I made it. Just an old-fashioned techno song. I made it. Just an old-fashioned techno song. I made it. Just an old-fashioned techno song. These days won't remember and all the way tomorrow used to glow. Future was bright, had to be
all
right.
Good seeing ya.
And you. Thanks everyone for listening.